High above us, satellites spin, their watchful eyes constantly scanning the Earth. These silent sentinels gather data, capturing every minute detail of our planet's surface. Recently they noticed something strange, something that has puzzled scientists and researchers alike. The land around Hudson Bay, that vast inland sea in Canada, is moving. This region, known for its stunning natural beauty and harsh climate, is experiencing a subtle yet significant shift. Not much, mind you, just a few millimeters a year. But even these tiny movements are enough to catch the attention of experts. But still, it's moving, rising up as if a giant hand is pushing it from below. This gradual uplift is a phenomenon that cannot be ignored. This is the Hudson Bay Anomaly, a curious case that has sparked numerous studies and debates within the scientific community. It's a mystery that has geologists scratching their heads. They are delving deep into the data, trying to unravel the secrets hidden beneath the surface. What could be causing this uplift, this slow but steady rise in the Earth's crust? Is it a natural process, or is there something more unusual at play? What forces are at play beneath the surface of our seemingly solid planet? Could it be tectonic movements, or perhaps something even more enigmatic? Some scientists believe it's the after-effect of glaciers, long melted, their icy grip on the land finally loosening. This process, known as isostatic rebound, is a well-documented phenomenon. Others suspect something more profound, something connected to the very heart of North America. Could there be deeper geological processes at work, reshaping the land in ways we are only beginning to understand? Whatever the cause, the Hudson Bay Anomaly is a stark reminder that our planet is a living, breathing thing, always changing, always surprising us. The Earth is dynamic, constantly evolving, and full of mysteries waiting to be uncovered. And sometimes those changes can have ripple effects far beyond their point of origin. The interconnectedness of natural phenomena means that a shift in one region can influence conditions in another, reminding us of the delicate balance of our world. To understand the Hudson Bay Anomaly, we need to travel back in time, millions of years ago, when glaciers ruled the North. These colossal ice sheets, stretching for miles, dominated the landscape, shaping the very ground beneath them. These mountains of ice, some thicker than a mile, pressed down on the Earth's crust, causing it to sag. The immense weight of the glaciers pushed the land down, creating a depression that would last for millennia. When the glaciers finally retreated, the land began to rebound, slowly springing back to its original shape. This process was gradual, taking thousands of years as the Earth's crust adjusted to the absence of the ice. It's like pressing your hand into a soft pillow and watching it slowly regain its form after you lift your hand. The land, much like the pillow, has a memory of its original shape and strives to return to it. This process, known as isostatic rebound, is still ongoing. The Earth is continuously adjusting, a testament to the dynamic nature of our planet. But here's the puzzle. The rate of uplift around Hudson Bay is faster than expected. Scientists have observed that the land here is rising more quickly than in other regions. It's as if the land is remembering something, some ancient trauma, and overcompensating in its recovery. This rapid uplift suggests that there might be more to the story than just the retreat of the glaciers. This begs the question, is isostatic rebound the only force at play? Could there be other geological processes influencing this phenomenon? Or is there something else, something deeper, driving this unusual uplift? The mystery of Hudson Bay's rapid rise continues to intrigue scientists, prompting further exploration and study. Thousands of miles away from the icy shores of Hudson Bay lies Yellowstone National Park, a land of geysers, hot springs, and simmering volcanic activity. It seems impossible that these two places, so geographically distant, could be connected. Yet, beneath the surface, a hidden link might exist. The Earth's crust is fractured into a mosaic of tectonic plates, constantly shifting and grinding against each other. These movements create stress that can propagate through the crust, like ripples in a pond. Some geologists believe that the uplift in Hudson Bay could be generating stress that's being transmitted southward, along ancient fault lines, all the way to Yellowstone. It's a complex and controversial theory, but one that could have profound implications for the volcanic system beneath Yellowstone. Section 4, the ancient heart of a continent. To understand the potential impact of the Hudson Bay Anomaly on Yellowstone, we need to delve deeper, beneath the Earth's crust, to the North American Craton. The Craton is a vast, ancient, and incredibly stable chunk of continental crust that forms the geological heart of North America. Think of it as the bedrock, the foundation upon which the continent rests. It's been through multiple cycles of mountain building, volcanic eruptions, and glacial periods, yet it has remained largely intact for billions of years. But even cratons, those bastions of geological stability, are not immune to the forces at play within the Earth. The question is, could the stress generated by the Hudson Bay anomaly be enough to reawaken ancient faults within the craton, potentially impacting Yellowstone? Section 5. Whispers in the Earth. The evidence. The idea that the Hudson Bay anomaly could trigger volcanic activity in Yellowstone might seem far-fetched. But there is some, albeit limited, evidence to support this claim. Seismic studies, which use sound waves to image the Earth's interior, have revealed a network of ancient faults and weak zones within the North American craton. These faults, long dormant, could act as conduits for stress to travel southward from Hudson Bay. Furthermore, GPS measurements show that the Yellowstone caldera, the massive crater formed by a previous super-eruption, has been rising and falling slightly over the past few decades. While this movement is not unusual for an active volcanic system, it does suggest that the caldera is sensitive to changes in stress and pressure. Section 6. A sleeping giant stirs. Yellowstone is a sleeping giant, a supervolcano capable of eruptions thousands of times more powerful than anything humanity has ever witnessed. Its last super-eruption, some 640,000 years ago, ejected enough ash and rock to bury an area the size of Texas under a meter of debris. The thought of another such eruption is terrifying, but it's important to remember that Yellowstone is constantly monitored by scientists. They track every tremor, every change in ground deformation, every burp of gas. So far, there's no indication that a super-eruption is imminent. However, the potential link between the Hudson Bay anomaly and Yellowstone is a reminder that we live on a dynamic planet, one capable of both subtle shifts and cataclysmic events. Section 7. Silence before the storm. So, what is the government doing about all of this? The question looms large as the potential threat of a Yellowstone super-eruption hangs over us like a dark cloud. The truth is, there's not much that can be done to prevent a geological event on the scale of a Yellowstone super-eruption. The sheer magnitude of such an event is beyond human control, and it serves as a humbling reminder of nature's power. However, agencies like the United States Geological Survey, or USGS, are constantly monitoring the situation, using the latest technology to assess the risks and develop mitigation strategies. They employ a range of high-tech geological instruments and have teams of dedicated researchers in the field, working tirelessly to understand the complexities of Yellowstone's volcanic system. The USGS has also been working to educate the public about Yellowstone's volcanic history and the potential hazards of a future eruption. Through educational seminars, public awareness campaigns, and informative displays at the Yellowstone Visitor Center, they aim to keep the public informed and prepared. They emphasize that while the probability of a super-eruption in our lifetime is extremely low, it is not zero. This cautious approach ensures that people remain aware of the risks without causing unnecessary panic. The Hudson Bay anomaly, while still not fully understood, serves as a stark reminder of the interconnectedness of our planet's systems. It highlights how geological events in one part of the world can have far-reaching impacts on ecosystems and human societies elsewhere. It highlights the importance of continued scientific research and the need for preparedness, even in the face of seemingly distant threats. Preparedness drills and community emergency planning sessions are crucial in ensuring that we are ready to respond effectively should the unthinkable happen.